Hello students, welcome to my channel Engineering Education. Please subscribe my channel. Thank you. In this video we are going to solve problem 13.6 from chapter number 13, reciprocating internal combustion engines, from the book Applied Thermodynamics by T.D. Staff and McConkey. The statement of problem 13.6 is: 4-cylinder 4-stroke diesel engine has a bore of 212 mm and a stroke of 292 mm. At full load at 720 revolution per minute, the brake mean effective pressure is 5.93 bar and the specific fuel consumption is 0.226 kg per kilowatt hour. The air-fuel ratio is determined by exhaust gas analysis is 25:1. Calculate the brake thermal efficiency and the volumetric efficiency of the engine. Atmospheric conditions are 1.01 bar and 15 degrees centigrade, and the net calorific value for the fuel may be taken as 44,200 kilojoule per kilogram. So first of all we will write the given data, which is mentioned in this statement. So we have given that it is 4-stroke and 4-cylinder engine, means that small n is equal to 4. Also, the bore of the engine is represented by small d, 212 mm, or in meter it is 0.212 meter. L is given, that is length of stroke or stroke, capital L is 292 millimeter, which is 0.292 meter. Engine speed is given, capital N, 720 RPM, or if we convert it to RPS, we will divide it by 60, so it will be 12 RPS, revolution per second. Also, the brake mean effective pressure BMEP is equal to how much? It is 5.93 bar. So converting it to Pascal, we will write 10⁵ factor with this. Specific fuel consumption SFC is 0.226 kilogram per kilowatt hour. So if we convert it to kilogram per joule, so we will divide it by 3600. So dividing it by 3600, we get 6.277 into 10⁻⁻8 kilogram per joule. Air fuel ratio A by F is 25/1. Atmospheric conditions are given. Pressure is 1.01 bar. So converting it to Pascal, we will write 10⁵ factor with this as well later on. Temperature is 15 degrees centigrade. So adding 273 with this 15 degrees C, we get 288 Kelvin. Also, the net calorific value is equal to 44,200 10⁻³ joule per kilogram. Kilojoule is converted to joule per kilogram. So we are required to find two quantities in this problem. One is the break thermal efficiency. So we are required to find first the break thermal efficiency and second the volumetric efficiency. These two efficiencies are required to calculate from the given data. So now starting the solution of the problem, we know that for break thermal efficiency we have an expression, that is break thermal efficiency is equal to break power divided by mass flow rate of fuel into net calorific value. So this is the expression. Let's suppose this is expression A. So now in this problem we have given the value of net calorific value and the break power and mass flow rate is missing. So we will find the break power and mass flow rate first. So as we know that break power in this case is equal to PB, that is mean effective pressure, break mean effective pressure, into area into L, which is stroke, into small n, which is number of cylinders, into capital N, engine speed, divided by 2. This is the expression for break power. So putting the values in this, break power is equal to 5.93 10⁻⁵. A is 5/4, so pi, d square, d is 0.212 square, into L, L is 0.292, N is number of cylinders, 4 into 12. 12 is the RPM, engine speed in RPS, revolution per second, divided by 4 into 2. So 5/4, so 4 will be written over here into 2. 2 is here. So simplifying this, break power is equal to 1.467 into 10⁵ watt. So this is second thing which is required, that is the value of mass flow rate for the fuel, or the volumetric mass flow rate, fuel mass flow rate. So to find the mass flow rate for the fuel, we know that specific fuel consumption SFC is equal to mass flow rate of fuel divided by break power. So here break power and SFC is known, so we will find m dot f. M dot f is equal to SFC into break power. So now putting the values, m dot f is equal to SFC is how much? It is 6.277 into 10 raised to power minus 8 is calculated and is given 6.277 10 raised to power minus 8. Also, the value of brake power is 1.467 into 10 raised to power 5 watt is calculated over here. So the value of mass flow rate is equal to 9.208 into 10 raised to power minus 3 kilogram per second. So these two quantities are known to us. Putting these values in expression A. So expression A will become brake thermal efficiency is equal to brake power is how much? It is 1.467 into 10 raised to power 5 divided by m dot f is 9.208 into 10 raised to power minus 3 kilogram per second, and the value of Q net, that is net calorific value, that is 44,200 into 10 raised to power 3 joule per kilogram. So when we simplify this, we get the value of brake thermal efficiency, and it is equal to 0.36, or in percentage it is 36%. So this is the required value of brake thermal efficiency. Now second, we are required to find the value of volumetric efficiency. So we have, this is suppose part 1 and this is part 2. So the expression for volumetric efficiency is equal to volume flow rate of the air divided by swift volumetric flow rate. Let's suppose this is expression B. So over here, volumetric flow rate of the air and swift volumetric flow rate both are unknown. So first we will find the value of swift volume flow rate, that is V dot S, and this expression for this is AL N capital N divided by 2. To express it in cubic meter per second, we will divide it by 60. So this will become AL N capital N over 120. Now putting the values in this expression, A is the area and it is pi by 4d square. So pi d square, d is how much? It is 0.212 meter divided by 4 into L. L is how much? It is 0.292 meter. Number of cylinders are 4 and the engine speed is 720 rpm. Also there is 120 over here, so we will write it over here 120. Now simplifying this, finally the value of swift volume flow rate is equal to 0.2473 cubic meter per second. Further, to find the value of air flow rate. So for that, first of all we will find the mass flow rate of the air. So we have air fuel ratio equal to mass flow rate of air divided by mass flow rate of fuel. From this we will find the mass flow rate for air. So it is equal to air fuel ratio into m dot f. Air fuel ratio is 25/1 and mass flow rate is calculated above. It is 9.208 into 10 raised to power minus 3 kilogram per second. So when we simplify this, we get the mass flow rate for air, and it is 0.2302 kilogram per second. Now further, to find the value of volume flow rate for air using the perfect gas equation, PV dot is equal to m dot RT. So for air it will become A in subscript. So rearranging this expression for volume flow rate. So volume flow rate for air, it is equal to m dot A RT divided by P. M dot A is known to us. It is calculated over here, 0.2302 into the value of R for air is 287 joule per kilogram per Kelvin, and the value of T is given over here 15 degrees centigrade or 288 Kelvin divided by P. P is the pressure and it is 1.01 bar. So we will convert it to Pascal multiplying 10 raised to power 5 factor. So the value of volumetric flow rate is equal to 0.1884 cubic meter per second. So now both values are known to us, that is the swift volume flow rate and the air volume flow rate. Simply putting these values here in this expression V, so volumetric efficiency is equal to 0.2473 divided by 0.1884 cubic meter per second. So when we simplify this, we get 71.16%. So this is the required value of volumetric efficiency, and it was all about the problem solution of 13.6. So if you like my videos, please don't forget to subscribe my channel. Also, to get notification for the upcoming videos, kindly share and like my channel. Thank you. Thanks for watching. Please like and comment on my videos. Also subscribe my channel to get new videos.